All right. So, welcome to the slideshow Rocks Rock. This is kind of our introductory, our jump into geology. And we're going to start with learning about the rock cycle and the three main kinds of rocks. So, this is our starter question for the day. You can probably skip past this because you know where to find your starters. All right. So, like I said, rocks rock. It's cheesy, I know, but they are really pretty sweet. There are some amazing examples of geology really throughout the world, but especially in Utah. We honestly have, I would say, the best geology in the world overall. For example, this right here, the arch, what we're famous for, made by geology. This is right on the southern Utah Arizona border. It's called the Wave. It's awesome if you've never been there. This is in Littleton, Colorado. I'm not sure exactly where this one is, but I do know that this is over in Wyoming. It's called Devil's Tower, and yeah, you guessed it, geology made that as well. So we're going to learn some of the processes that formed all these types of rocks. So one of the main reasons I like geology is because studying geology is kind of like being a detective. Like you're seeing the evidence of what happened millions and even billions of years ago. Yeah, we've got rocks on the earth that are over a billion years old. It's crazy. So when we look at them, they can't speak for themselves, but they can tell us a story of what has happened to them over that time span. So we get kind of like a sneak peek into what happened in the past, just like a detective would come to a crime scene and see like, the details, the clues that have been left around and be able to put together, what happened in that crime scene just by looking at the evidence. So there are three main types of rocks, and you're probably pretty familiar with this. I think you start studying these in like first grade. But we're going to go a little bit deeper. So there are igneous rocks, there are sedimentary rocks, and there are metamorphic rocks. And these are three examples right here. So talk to your neighbor. But if you're watching this, you probably are at home. So don't talk to your neighbor. This is for when we're in class. But think for yourself right now. Do rocks change what type they are? Like once you're an igneous rock, are you stuck being an igneous rock for time and all eternity? Once you're metamorphic, is that just what you are forever? And the answer is actually no. Rocks can cycle through all three different types of rock over and over and over and over. It's kind of like the water cycle, but not as fast. So if you think about the water cycle, we have liquid water and we've got like solid water in the form of ice, and we've got like water vapor, which is in the gas form. And a molecule of water can cycle through those three stages over and over and over, right? You can be some water vapor because of condensation, you're now part of a cloud, and then precipitation happens and you rain and you're liquid, and then it freezes and now you're solid, and then it gets warm again, so you melt and you're liquid again, and then it gets really hot, so you evaporate, and it just goes over and over and over, right? That's similar to what rocks do, but it generally takes a little bit longer, actually a lot longer, to go through these cycles. And there's not just one particular path. Like it's not like it's just doing the same pattern over and over and over. Um, Rocks can kind of switch things up. Like you can go from igneous to sedimentary and then back to igneous and then back to sedimentary and then back to igneous and then go through metamorphic and then back to sedimentary. Like you can really go anywhere you want through this cycle, but they're constantly bouncing between these three types, of course, over millions of years generally. And we're going to talk about how. So there's a video right here. I'm not going to have us watch it during this video just for the sake of time, but you can watch this video on your own. It shows the Hawaiian volcano erupting. Honestly, it's crazy. It's pretty sweet, although really destructive if you live near it. But this picture will do the trick. You guys have seen videos of volcanoes, or at least you have an idea of what they look like. Our Earth is divided up into layers. And on the very top, we have the crust. We'll learn more about this in a few weeks. Beneath that, we have the mantle. And while the crust is pretty cold and solid, the mantle is a little bit more movable. It's heated up enough that there is some flow. There can be some flow to it. And Whenever there's a gap, there's pressure that is released, and lava, or I guess it's magma when it's underneath the ground still, flows up through that crack and erupts out of the top. So I kind of like to think of it as like when there's no crack, it's kind of like you have a brand new bottle of like Dr. Pepper, and there's a lot of pressure. The bottle's been shaken up, but there's no crack, so the magma just stays underneath, or the Dr. Pepper just stays calm and docile in its bottle. But as soon as you crack the lid, that Dr. Pepper wants to erupt out, right? It wants to get to the surface because there's a lack of pressure. So it flows to that pressure difference. And that is why we have volcanic activity. Just high pressure under here, like that shaken up Dr. Pepper bottle, and low pressure up here at the surface. So magma erupts. Once it hits the surface, we call it lava. So moving forward, when that magma or lava cools, it forms igneous rock. So it forms two main categories of igneous rock. It can form this type over here, like this smooth, glassy rock kind, or it can form this type over here where it's more chunky and there's crystals. So these two main types of igneous rock are called extrusive and intrusive. And here's why they have those names. Extrusive comes from the prefix like X, meaning like the exterior. Think about like the exterior of your house. That means the outside of your house. And extrusive rock, it cools down on the surface of the earth. It cools down extrusively on the outside, basically. And because of that, it's actually pretty cold up here compared to the warmth of, the deeper you go into the earth. So because it's kind of cool up here, it cools down really fast, and it basically just hardens like right into glass pretty quickly. And so we don't have time for any minerals to form. We generally just get one color, and it's pretty glassy, just like that. Now, on the other hand, let's say that volcano erupted, and the stuff that came out the top cooled down into maybe something like this, but maybe some of that lava didn't get to flow all the way out. Think about the Dr. Pepper bottle again. When you open that bottle, does every last drop come right out? No, you're going to have some that comes out, right? And gets all over your hand and it's annoying and sticky. But you're also going to have some that stays on the inside of the bottle. So some of this rock, it might come partially up, but it doesn't come all the way out. And so as it gets farther away from the middle of the earth, it is getting cooler and cooler and cooler. So it might reach a point where it cools down enough to harden into a solid rock, but it doesn't cool down very quickly because it's still pretty warm in there. Um, so as this is cooling down, it's taking a lot longer. And because of this, the minerals that are inside of this material, they might even be the same minerals. But since this has such a longer time to cool down, the minerals, or like the atoms inside this material, this magma, they have time to flow around a little bit first. And as they flow around, they generally find each other and they form chemical bonds. Now I know we don't talk about chemical bonds a lot in 7th grade, but it's when those molecules stick to each other. And as these molecules start to grow, it's kind of like a snowball. You push a snowball around outside on your lawn after it snows, and the more you push it, the bigger it gets, and it just starts adding and adding and adding until you have a gigantic snowball, right? Well, the longer this material has to cool, the more of those atoms stick to each other because they like to form bonds with each other. It's like finding your friends like on the playground. You might be all mixed up at first, but you're going to conglomerate, or you're going to find your friends and stick with each other. And so you start to form crystals. And that's why we have these two different colors in this particular rock. We have these lighter colored, like these white crystals right here that are forming. And then we have these black crystals right here that are forming. And these are just the two examples I picked. There are all sorts of different rocks that fit in the extrusive and in the intrusive categories. Okay. So again, this one cooled down really quickly on the outside of the earth, on the exterior. That's why it's extrusive. And this one cooled down really slowly on the inside of the earth or beneath the surface. So it's intrusive, like the interior of the earth. And it had time to let these crystals start to build and to start to form. Okay, so we got those two main big categories. So turn to your neighbor. Again, you're watching this at home probably, so you're not going to be turning to your neighbor. But where would you expect an extrusive rock to form just by looking at this diagram? Hopefully, you can say, well, if it's extrusive, we're talking here on the surface. Now, where would you expect intrusive rock to form? Hopefully, you're thinking like right in here, where it came up partially, but it didn't come all the way to the surface. So it cooled down enough to harden, but it's not going to cool very fast. It's still got a lot of blanket of earth on top to keep it warm. So that's where you would find those intrusive rocks. Okay, so igneous. I know in your language arts class, English language arts class, you're learning about Latin and Greek roots, and here are a couple for you. So the prefix ig, or that root right there, it means fire. So think of like ignite. Like if you're going to ignite a fire or ignite something, that means you're lighting it on fire, right? So ig means fire, and neo means new. And it basically says new right there, right? Just one letter off. Neo means new. So igneous rocks are like brand new rocks that are formed from fire, meaning like from the heat of the earth. That's what creates them. So that's how I remember igneous rocks. So here's another example of an igneous rock, and it doesn't look like those two examples I showed you earlier. Here's the thing about rocks. Here's the thing about rocks. There are like, I don't know, hundreds, if not thousands, probably thousands of different types of rocks, and we try to cram them all into three categories. So it's not all just plain and simple cut and dry. Some of them are a little bit more difficult to identify than others. This one, once you learn why it's an igneous rock, it'll be really easy to remember still, even though it doesn't look like those first two examples. So take a look at this rock and see if you can figure out what might have caused all these little pockets. So the reason these little pockets or these little holes are there is because bubbles there are gaseous bubbles inside the magma. Again, think of that Dr. Pepper bottle. When you crack open the lid and you release that pressure, you don't just get a spray of Dr. Pepper coming out in pure liquid, right? You actually get that foam that comes out. It forms bubbles. Sometimes that happens with volcanoes too. So they're called vesicles. And if they have vesicles, then they are vesicular. So this is a word that we can use to describe an igneous rock. We can say it is vesicular. It has vessels, aka it has little pockets that are made by bubbles. Again, you can watch this little clip from Finding Nemo. I like it. It talks about bubbles, but it's not important. So we're going to move on. So, oh, no, it's going to play anyway, it looks like. Okay. So anytime you see these little pockets of air, those were formed by bubbles. But as those bubbles were forming and trying to escape, the rock was cooling down. And most of the time, this means that the rock cooled down quickly enough that the bubbles didn't have time to escape, and the rock hardened and they were trapped there. So as the rock hardened, it formed around these little pockets. It's kind of like if you like instantly froze that Dr. Pepper that it was erupting out of the bottle. If you like took a snapshot of that, you would see all those little bubbles, and that's kind of what happened. So any rock that has any of these igneous rocks that have these bubbles, those vesicles, they are vesicular. That's how you would describe them. And then a rock that doesn't have any little pockets, we're going to call that non-vesicular. Okay. All right, moving on to our second type of rock, sedimentary rock. So these personally are my favorite because this is what Utah is famous for, and I love it. So sediments. The word sediment is just a tiny little piece of dirt or rock or mud that is being moved around. So I like to picture like these great sand dunes with the wind blowing. Those tiny little pieces of sand, those are sediments. These little pebbles, they can also be sediments. So what is a sedimentary rock? Again, we're not going to watch Shrek. Sorry if you weren't here in class. We did watch a lot of fun videos today. But no, thank you, Donkey. All right. So sedimentary rocks often form layers. We'll talk about why later on, but basically, as these sediments come from different locations, they pile up in layers and they stack up on top of each other. And we can see those layers often in canyon walls, especially in southern Utah, but really everywhere. I mean, it's a whole category of rocks. So we often see layers when we're seeing big outcrops or big hunks of sedimentary rock, but not always. Okay, so what is the difference between these two rocks? They are both sedimentary. Hopefully, you notice that this rock is made up of gigantic, or I mean, not gigantic, but pretty good sized chunks, right? Or good sized sediments, if we're going to use the more sciencey word. And this one, it's still a sedimentary rock, but it's not made up of as big of chunks. This is just kind of tiny little specks of like sand. And in fact, this is a sandstone. Any any sedimentary rock that looks like this, where it's got those big hunks of a whole bunch of different rocks, this is called a conglomerate. And usually you would find this when like a riverbed dried up and got turned into rock. And we're going to talk about the process of that here in a few minutes. But doesn't this just remind you of like the bottom of a riverbed? That's where it was at one point. So small sediments versus big sediments. That's really the difference here. But the processes that made these are pretty similar. So in order to make a sedimentary rock, first you need the sediments there. You need like the raw building materials. You need pressure to squeeze those things together and to turn them into a rock. And you need time, right? This doesn't just happen overnight. So we got sediments plus pressure. That guy looks like he's being squished by the pressure of that rock, plus time. All right, metamorphic rocks. This is the third type of rock, and I saved it for last because it is actually what happens when damage gets done to either an igneous or a sedimentary rock. Life isn't always easy if you're a rock. Sometimes you're living life on the surface, you're at the top of the mountain, everything feels great. And the next thing you know, a million years later, a mountain has formed on top of you and you are getting squished to death. You're like the bottom person, like at the bottom of a doggy pile in football. It's rough. So this creates metamorphic rocks. Now, I want you to think where you've heard that word before, metamorphic. What does it mean? The first thing I ever learned about metamorphosis was about butterflies. When metamorphosis happens to this caterpillar, it changes into something completely different, right? It starts out as this lowly little caterpillar, goes through kind of some awkward time, and then before you know it, it's a beautiful butterfly. And that is metamorphosis. Well, rocks kind of do a similar thing, although we don't get butterflies out of it, but we do still get something pretty cool. We get these changed rocks, and that puts them into their own category of metamorphic rocks. So, this is what it takes to become a metamorphic rock. You start out as either igneous or sedimentary, but then things start heating up. Again, the deeper you go in the earth, the warmer it gets. So, if you get buried by a mountain, it's going to get toasty. That's a lot of pressure. And then, yeah, pressure is the second one actually. And so I've got this little picture of a guy getting squished by a gigantic hand. So you got heat, you got pressure, and again, it takes time. Metamorphosis is not going to happen overnight. For rocks, it can take, I mean, a long time, long, much longer than like the 5 days it takes a butterfly or whatever it is. We're talking like millions of years. So metamorphic rocks have two main categories. And one type is metamorphic rock with foliations. So a foliation is like a visible line in the rock. Like if you can see like these horizontal lines right here that have kind of been squished, like they're not perfect straight lines, but that is a foliation. There's a line in the rock. So this is an example of a metamorphic rock with a foliation. So this original rock started out as igneous. It's a granite. Just like we learned about with igneous rocks, first it has these big crystals, right? It cooled down slowly. It's intrusive. But then the weight got too much and it got buried. So it got squished and it got partially melted. Now it's important that you remember the word partially melted because, whoops, if it completely melted and turned back into like magma or lava, then it wouldn't become a metamorphic rock. If it turned back into magma and then it cooled down again, it would just be a new igneous rock. But it melted just a little bit and then it got squished. I kind of like to think of it like this. If you um, put a marshmallow just straight in the microwave for 5 minutes, what's going to happen? It is going to melt into oblivion, right? There's going to be a puddle of marshmallow in there, and that is what happens before igneous rock forms. So like it comes from completely melted, and then it cools down and forms a new rock. When you partially melt something, like what you do with metamorphosis, it's more like you put the marshmallow in your pocket. It doesn't it doesn't turn into liquid, but the warmth of your pocket from like your body heat makes it so it warms up enough that it's flexible, right? It's squishy, and that's enough for it to change and to become a metamorphic rock with enough time, heat, and pressure. So here's another example of a metamorphic rock with foliations. So this one comes from a sedimentary rock. So this sedimentary rock, it gets squished, it gets partially melted, and it starts to form these weird, squishy looking, shiny crystal things. So, this again was a sedimentary rock, and then a mountain sat on it for probably a few million years or tens of millions of years. And you can kind of see how it's been like condensed and squished, and you see these rough horizontal lines starting to form. This rock is called a schist, schist. And no, I didn't just cuss. It's actually called a schist, and it came from a sedimentary rock at one point, but now it's been squished. It's metamorphic, and it's a completely different type of rock because of the heat and the pressure. So again, the foliations. We don't just have straight up lines right here, but you can see how it runs back and forth horizontally, right? Because the pressure came from the top and squished down. It's kind of like a sandwich that's been sat on. All right, now here's our other type of metamorphic rock that we're going to learn about. These are metamorphic rocks without foliations. So these ones did have foliations, they had those horizontal lines happening. This one does not have a foliation, or it does not have foliations. So this is usually caused by more heat and a little bit less pressure. So in this case, we have a sedimentary rock. This is a limestone. You add some pressure still, and you add a significant amount of heat, and you kind of remelt it just a little bit, not all the way, but as it melts and then recools just a little bit, you've allowed it to you've allowed those minerals to move around just a little bit as they were kind of squishy, and there was enough pressure that they changed their form. The atoms changed their bonds and which way they were organized, and now you, instead of having a sedimentary rock like this, a limestone, now you have marble, and now this is something that you would want to make a marble countertop out of, and that is metamorphosis. So as these materials move back and forth and through this cycle, as they change from one type of rock to another, we call it the rock cycle. So you can, and you will, draw a diagram similar to this, but there's a million ways you can do it. But you can see how it's not just one continuous circle. But you can take a shortcut here, and then you can head up here and take a left here. There's a lot of different directions you can go. It all depends on what process you went through to get there. So we're going to talk about the processes that happen now. So crystallization. This is a process where hot liquid rock, like magma, as it cools, it forms crystals. This is called crystallization, and it's how we get igneous rock. So again, we have these two different types of crystals. We've got the mica and we've got the quartz, and this could have been a dozen different types of materials. This is just the one I found on Google. But as this liquid magma cools, it crystallizes and it forms igneous rock. So crystallization is the process. It cools and it crystallizes. All right, weathering. So weathering is the process of rocks being broken up into smaller pieces. So you can see this poor rock looks like it's been hit by Thor's hammer. it is starting to break up. It's starting to fall apart. And this happens over time as water and rain and the wind and, you know, a horse steps on you and you fall off a cliff and you land at the bottom. Weathering causes you to break up. You slowly start to fall into pieces. So one of the main processes that causes this is the freeze, thaw, and refreeze cycle. So I would encourage you to click on this video as you go through the slideshow on your own. It does a great job of showing how this happens. But as water fills in the cracks and freezes, it expands. As it expands, it kind of pushes the rock on both sides and breaks little bits of it off. And then the next morning, when it warms up, that ice melts. Then, of course, night comes again, and the water refreezes, and it just goes over and over and over, and all the little cracks in a rock get slowly forced apart, kind of like this, because of weathering. And it's a very, very slow process, usually. It can take a long time. Oops, don't want to watch that right now, but I encourage you to. Another process is called erosion. I know you've heard of this before, but as small bits of dirt and rock get moved somewhere else, this is erosion. So weathering is when they fall apart. Erosion is when they start moving. So wind can pick up like our first picture we saw of sand being blown off sand dunes. That is erosion. That's when water or wind or whatever it is, gravity, moves these tiny little bits of dirt and rock somewhere else. And then deposition happens. So as deposition happens, that means those sediments are dropped off. So think of this process kind of like UPS. So at some point, that package is like, let's say that package is at the factory. It's a new iPhone, so it's at the Apple Store. And then it gets moved out of the Apple Store by erosion, and then it gets delivered to your house. And when it gets dropped off at your house, that is deposition. It's in its new home. So the reason I put these pictures up is because, as you can see, there are two canyons shown right here. Canyons are like these super factories of geology. Weathering is happening because of all the water and the wind whipping through there. And erosion is happening because usually canyons form where there's like a downhill slope, right? They're coming out of a mountain. So water is carrying these particles or these sediments, these little pieces of dirt and rock, through the canyon. And then eventually it's got to drop off the package, right? It's got to drop off the sediments. And so as it comes out of this canyon and the water slows down, the water drops off its package. It drops off all these little bits of rock and dirt, and they are deposited or deposition. That's when things are dropped off. And so you get like this big kind of garbage pile at the mouth of canyons, and this is called an alluvial fan. That's not going to be on your test, but just the more you know, because it's kind of fan shaped, right? When you see like this gigantic garbage pile of dirt and rocks at the mouth of the canyon, it's called an alluvial fan, and it's basically just a gigantic place of deposition for a canyon. All right, the next word I'm going to introduce is lithification. So this comes from the root word lith, and this means rock. Okay, so rock. Oops, I don't want to watch that. Oh no, let's go back. All right, so this is how sedimentary rocks are actually formed. Like this is the forming process right here. So when these sediments have been deposited, they get glued together by pressure. So imagine you're one of these first rocks down here to get deposited. And then everything's fine, you're on the surface, no pressure. But then over the next million years, all these other layers start piling up on top of you. And now things are getting a little squishy, right? And you start to get glued together with all the other sediments around you. And before you know it, you're part of a brand new rock. And now you're a sedimentary rock. You might have started out as metamorphic, you might have started out as igneous, but now that you've been glued with all those other sediments, now you're a sedimentary rock. And that process of the gluing, the sticking together by pressure, that is lithification. Okay, so the last word I'm going to introduce to you is deformation or deformation, however you want to say it. So as something deforms, that means it is changing its form, right? It's changing the way it looks, and this is really what happens during metamorphosis. So when time and pressure and heat all add up to, squish, let's say in this case, an igneous rock into something else, a metamorphic rock, that process, like if I could label these arrows, I would. That process is called deformation or deformation, however you want to say it. So whenever you get one rock changing into a metamorphic rock, it's deformation. Okay, so you might be wondering why, when this rock gets squished, does it form like these nice, clean bands of like black and white and gray and all the other colors mixed in here? Why doesn't it just have squished speckles like this? Well, it's kind of an advanced concept, but I'll see if I can break it down simply for you. Imagine you have a box of Legos and they're just bouncing around randomly and they're getting squished, they're getting stepped on. The Lego pieces, they kind of want to stick to the other Lego pieces, right? Like that's kind of the way their little connectors want to stick together. And I don't know if you've ever played with Connects, that's these pieces right here. But the Connect pieces, they don't really want to stick to the Lego pieces. They don't form connections very easily. So what they try to do as they get squished, um, they try to find each other. Now, if this was an igneous rock, these let's look back here. These rocks, they might not have had enough time to all find each other. That's why you have different, speckles of black and white throughout this rock. But then as it gets squished and pressed, it partially melts, which means it turns just soft enough where they can start to wiggle around a little bit. And what they do is they find their buddies. They start to find the things that they don't want to form bonds with. And you go from kind of this random assortment, you kind of go from this random assortment to a more linear